Hey everybody, welcome to Eureka Math / Engage New York Math, Module 6, Lesson 6, describing the center of a distribution using the mean. When we talk about the mean, you may also hear that referred to as the average. The mean and the average are the same thing. I'm going to show you, there's kind of two methods, and Engage New York shows you a lot of different ways to do it. There's kind of there's many methods to look at the mean. I'm going to show you two of the ones that I want to talk about today. The first is called the fair share method, basically just balancing out a number line. And then the second is, I just want to show you the kind of traditional way of finding the mean based on an algorithm. So let's go ahead and get started. A student, let's say Michelle, asks 10 classmates for the number of hours they usually sleep when there is school the next day. They say 8 hours, 10 hours, 8 hours, 8 hours, 11 hours, 11 hours, 9 hours, 8 hours, 10 hours, and 7 hours. If we were to make a dot plot to show you what this data looks like, it might look something like this. Okay, I did my range, which is from 7 all the way up through 11, right? And let's go through. We have an 8 here, so I'll cross out. We have another 8, so we have 3 8s. Make that 4 8s. We've got a 10. We've got 2 11s. We have a 9. We have another 10. We have a 7. So you see kind of our distribution of numbers here. If I ask you what was the center of this data, what would be a good way to measure the center? Well, you might say, well, we've got 1, that's 7, 2, 3, 4, 5. So that's where the halfway mark is, and then here we have 1, 2, 3, 4, 5. So you might say it's around 8 hours. Seeing as how there's more, seeing how there's 5 on each side, right? If you call this 8.5, it's not very good writing. 8.5. There's 5 fewer than 8.5, and there's 5 more than 8.5. The most number of responses was 8, so you might say it's around 8. Would that be accurate? Does that make sense? It looks close, right? Now, what's the problem with it? Well, if we're going to say around 8.5 is right in the middle, right? We have a lot more that are higher than 8, and here we have a lot that are concentrated in 8, which kind of brings it closer to 8, whereas the actual middle may be a little bit higher. Now, if we want to look at what the actual mean would be, then what we would do is we'd say, okay, we've got 1 7, so that's 7. We have 4 8s, which is 32. We have a 9. We have 2 10s, which is 20. And we have 2 11s, which is 22. When you add all those up, all of the students slept 40 hours. If you divide 40 hours divided by 10 students, if we were going to say they each slept the same amount of hours, that would be what the average is, right? And we would actually get 9. So while it may look like the most appears at 8 and the middle of the data would be 8.5, we'll talk about kind of why that is at a later date, but the average right now would be 9. So if they all slept the same amount of hours and they all slept those 40 hours combined, they would have each slept about 9 hours. That's the average. Now you can see why it's not 100% accurate, because more kids slept 8 hours than 9 hours. Of all those 10 kids, only one of them slept 9 hours, but the average for the whole data set is 9, right? So hopefully you can see why the average could be good to use, but why it also can be a little bit misleading, because when you have a lot of numbers congregated in one area, such as the 8 hours, or when you have a couple of higher hours, right, like 11, then you get to a point where there's 2 11s and only 1 7, so it kind of stilts it in this direction, if you want to think about it as a balance. So if we do want to think about it as a balance, let's look at that. Let's look at an example together. Okay, let's say this is a dot plot on the number of pets. and we asked 1, 2, 3, 4, 5 different kids the number of pets. So we've marked it. So there's one kid who said, I have 1 pet. 2 different kids said they each had 2 pets. One kid said, I've got 4 pets, and one kid had 6 pets, right? Maybe some of those are fish or something. So if we look at this data and we wanted to kind of see where would these all meet if they were going to meet in kind of an even-handed way, right? Well, what we might do is we might take this 6 and have it jump down to where we now have 2 above the 4. And then we might take this 1, bump it up here, so we have 3 on the 2, 2 on the 4, and then let's start meeting in the middle, right? Let's start moving them over. So we erase 1, put it here. We're going to erase this one. We're going to put it here. We're going to erase this one and put it here. And so now we have this kind of even distribution where we have the most that appear in the number 3 column. We have 1 on each side. And as we move the numbers into this kind of even distribution, now we have 2, 3, 3, 3, which is 9, and a 4. You add those all up and you have still a total of 15 pets. So if we said what is in the middle, we would say 3 is in the middle. Now, just to be clear, here's why that works. When we had, I'm going to draw it as a star so it's easier to see. We had 1 in the 1 column, and we had 1 in the, I believe we had 1 in the 6 column. Well, when we took 1 and added it here, that took the kid who had 1 pet and said they had 2. But then we took this 6 and moved it here to the 5. That said, well, the kid who has 6 pets now has 5. So we just basically took 1 pet from the 6 and moved it to the kid who had the 1. So then that kid had 2, and this kid now had 5. So when we're meeting in the middle, we have to make sure that we do that evenly, right? So we're taking these, we're taking this data, we're taking these numbers, and we're making them meet in the middle based on taking 1 away from 1 and 1 to the other, and then getting all the dots into one kind of central location. And so, same thing here where we have a kid with 2 and a kid with 4. If I move this here, that's giving that kid 1 extra and giving them 3. And if I move this here, that's taking 1 away. So this kid gets an extra, this kid loses 1, and they end up with 3. And all our data is in the 3 column. So our average, if they all had the same number of pets, our average or the mean is 3. Now, let's look at that same data one more time. We had a kid with 1, we had 2 2s, we had a 4, and we had a 6 to start out with. We add all these together, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 15 total pets. How many people have pets? 1, 2, 3, 4, 5. If we divide the total number by the number of pets by the number of people who have pets, we end up with the same answer, an average of 3 pets per person. That doesn't mean they all have 3 pets. That just means that's the average of that data set, or the mean of that data set. Okay, some of this we'll be able to do a little bit more hands-on in class and be able to look at this together. So I'm going to stop there, and we will talk soon. Hopefully this helps, and you can go back and look at this, but we'll get into some different ways to find the mean, and we'll continue to work on this together. So we will talk to you soon. Thanks for watching.